All right, let's take a look at a precipitation stoichiometry practice problem. You have 100 mils of a 0.1 molar potassium sulfate solution, and it's added to a 100 ml solution of 0.2 molar calcium nitrate. Calculate the mass of the precipitate formed and the concentration of the remaining ions in the solution. We're going to do one thing at a time. I encourage you to pause as much as possible. You should be doing this with me. Don't simply watch it. Work the problem. So first, what do we always do? We need a chemical equation. In chemistry, you need to paint a picture, and a picture is a chemical equation. So I have potassium sulfate, and it's added to calcium nitrate. So please figure out that solution, the reaction. There are my reactants. They are both solutions. And this is a pretty straightforward double replacement reaction, making potassium nitrate and calcium sulfate. With your solubility rules, this should be an automatic, but that is AQ because it's an alkaline metal and it's a nitrate. Calcium sulfate is an exception to being soluble with sulfates, but that should not have been a huge leap because this said that there was a precipitate, so there has to be one. Make sure you do balance it. So there needs to be a 2. So organize your information. I have 100 mils of 0.1 molar here. And I have 100 mils of 0.2 molar here. It's asking for the precipitate. So let's solve it. This is a limiting reactant problem in the beginning. So I want to know how many moles I have of each. So simply put, I multiply the liters by the molarity. I get my moles. So there are my moles of potassium sulfate. And here are my moles of my calcium nitrate. Now simply eyeing that up, you probably can figure out which one the limiting reactant is. The only reason why I say that is that you can tell it's a 1-to-1 ratio, but we should still do that. So I'm looking at that and it looks like the potassium sulfate is going to run out first. Doesn't matter though. I picked either one. So let's do a mole ratio between the two. And as it says, you're going to need that much. Well, I have more than that, right? I have more than 0.01, so that's excess. So this becomes my limiting reactant, right? K2SO4 is my limiting reactant. So let's finish solving how much precipitate I'm going to make. So I'm going to take my amount that I have, that I started with, and now it's just mole ratio and you get this. And that's how much is formed. But really, this is probably not the hard part of the question. The hard part is the concentration of the remaining ions in the solution. That's what we need to calculate. So let's look at all the ions. If I just list them out, I have K plus, I have SO4 2 minus, I have Ca2 plus, and I have NO3 minus. If I bring my work from above, just to look at it, this will help me be able to illustrate this to you, what's going on. So, remember, we have spectator ions, we have ions that are completely consumed, and we have ones that are partially consumed. So, if we are looking at our equation, I can see that this is my precipitate right here, right? So, between either Ca or SO4, it's going to be completely consumed. So the trick is, which ion is in my limiting reactant? So I come up to the top of my screen and look, my K2SO4 is my limiting reactant. So what that means then is that this must be 0 molar. The reason why is that that one is completely precipitated out and is part of the limiting reactant. So the calcium is going to get somewhat consumed. We'll take a look at that in 1 minute. And that means these other ones are spectators. So that means that the numbers are purely coming from the moles that I figured out right away. So let's calculate those. Here we go. So first off, you got to have total volume. So I have 0.1 liters plus 0.1 liters, so that's 2 liters. And then if I look up here, here's my K plus, and I look, and this is where I'm looking right now, I have 0.01 moles of K2SO4. That's where I get the K from. But as we've been talking about, that's how many moles I have of K2SO4. So if I have K2SO4 here, and I have 0.01 moles of that, that means I have 0.01 moles of sulfate, and I have 0.10 moles of K plus, and I have another 0.01 moles of K plus. So each of these count towards that. So that's why I have to double 0.01. So if I calculate that out, I get 0.1 molar. Let's take a look at the other one. I have nitrate, and that comes from here with the 0.02 moles. So I have 0.02 moles over 0.2 liters because I have 0.1 liters and then another 0.1 liters. And again, the nitrate, there are 2 of them. So that's why I need to multiply that by 2. And I get 0.2 molar of that. So here we go on the calcium. Calcium is being consumed. So what I do first, when I have the 0.2 liters, okay, what did I start with? Here I am, calcium, right there. I started with 0.02 moles. And how much was consumed? Here's the trick. This is all going to get consumed right here, all of this. And how much does it need to react with the other stuff? Right here. This much CaNO3 is going to be consumed. That's how much is going to react. That's the hard one. So the 0.01 moles of Ca are going to be gone. They're gone. So that's Ca. So I'm going to subtract 0.01 moles. So what I get is I have 0.05 molar left. And that's how that's done. Now, I want to challenge you for a moment. Looking at those numbers, Hopefully you have that written. I have a little multiple choice challenge. Between these 4 beakers, looking at what was done, looking at your concentration numbers, which answer is the best? Which answer is the worst? I'd like you to pause it, and I'd like you to think about it. When you unpause it, I'm going to eliminate the one that should have been eliminated immediately. So please pause. All right, hopefully you have the answer completely, but let's get rid of one right now. If you're looking at A, B, C, and D, there's one that's clearly not right. The reason why that one's not right, there's no precipitate. There's no precipitate in the solution at all. And technically it's not in the solution, but in the beaker, okay? So if you're still having some troubles, pause it again, please, and think about ratio and what is present. All right, let's talk about this one more time. There's one other one that is not good in here as well. The other one you should have gotten rid of was because of this guy right here. There is no SO4 2-, so that can't be in solution at all. So that's got to be gone. So now it's between B and D. So if you look at B and D, the only real difference is specific numbers. So if we looked at it again, and we looked at our numbers, what we had said was K plus equaled 0.1, NO3 equaled 0.2, and K2 plus equal 0.05. So what does that show me? This one is double this, and this one is double this. So that means I should have quadruple the NO3s, double the K plus, 2 the CAs. So if I look at this right here, I don't have that many NO3s, but here I have 1, 2, 3, 4 NO3s, 2 Ks, and 1 CA. So this is the proper answer because of the mole ratios. Hope you did well. Good luck.